This is Algebra 1A, Unit 3, Lesson 13, Writing Equations Given a Verbal Description. So therefore, your objective for this lesson is that you can write an equation in slope-intercept form, this time when you're given as a verbal description. So some things you need to know. In your equation, when you have a story problem, you need to always be able to identify the slope, which in the story, it's going to be your rate. For example, $3 per hour, $3 per day, $2 an hour, $5 a person, $6 a minute. It's the rate, how much somebody's getting paid or how much somebody's getting charged. Okay, this number is always related to your x value. So in the equation, this number is always going to go right in front of x. Just like story problems that you had earlier in the course, you found out that your constant was a flat fee or a flat rate. This is going to be your y-intercept in the equation. So let's take a look at an example problem. Focus question number 1. You're visiting the most amazing city ever, Chicago, and the taxi company charges a flat rate of $3 for using the taxi, an additional 75 cents per mile. Write an equation that you could use to find the cost of the taxi ride in Chicago. Let x represent the number of miles and y representing the total cost. So let's identify those key terms in this story problem, or keywords. Okay, I zoomed in to get a closer look at this. Let's identify some of our numbers here. We have a $3.75. And basically, our two numbers in the problem, one's going to be our rate and the other one's going to be our flat fee. Well, your rate, the key word, as I said before, is per, or something for every, for each. That's also some of those key words. So, therefore, that 75 cents, there's that word per, that's per every mile. So that is your rate. Therefore, our other value, $3, must be our flat fee, and that makes sense, right? Because it even says flat rate right here. So once we identify our rate and our flat fee, or our slope and our y-intercept, now we're ready to write our equation. It says to let x represent the number of miles. Well, where is our miles in our problem? Well, our miles is that 70 cents per mile, all right? So that 75 cents needs to go right in front of that x, 0.75x. Now we are going to write these in slope-intercept form, so they say y represents that total cost. There's that word total, and we know from one of our previous lessons that total means equals, so y is equal to our 75 cents per mile, that x value, and then you just add on your $3, your flat fee. So you notice we have this in slope-intercept form, the y equals mx plus b form. Let's try another one. A plumber charges a fee of $50 to make a house call. He also charges $25 an hour for labor. Write an equation that you can use to find the amount the plumber charges for a house call based on the number of hours of labor. Let x represent the number of hours and y represent the total cost. Well, we know that when it says y is equal to the total cost, that they want this in slope-intercept form. They shouldn't even have to say, write this in slope-intercept form. So we know we want y is equal to, and they said let x represent the number of hours. Well, let's read through the problem, because this can even help us identify that rate and this y-intercept. So we know whatever hours number that's with hours in our problem, that is the number that goes in front of our x. So here we see hours again, or an hour, $25 an hour, so that's for every hour. They didn't have to say for every or for each. We know that it's implied. So you 25x And that leaves that flat fee that the plumber charges just for stopping by, regardless of how long he's there, of that plus 50. So there we have it in slip-intercept form. Now, unfortunately, it's hard to find or difficult to find lots and lots of story problems to practice with this. So the rest of your independent practice is actually guided practice. What we'll do is I want you to read through and see if you can identify some of the key words on the guided practice. Do it one step at a time, and then push pause. Push pause. Try as much as you can. Push play when you get stuck and start watching. If you can get through the entire problem and you got it all right, that's perfect. And you know what you're doing, and keep on going. So let's try several of these. Alright, these aren't numbered, so I'll just have to tell you which one we're looking at. Let's look at this problem right here, problem number 1. Let's see if you can start the equation. Can you identify any words or things that might indicate the rate? Or either the flat fee? I'll let you read the story. Our last sentence should give you lots of clues here. So have you written y is equal to? Okay, so x is supposed to represent the profit. Well, let's go back through the problem so you can find the profit. Mutual fund company, $50 a year, an additional 2% of the profits. There's that word profits. So you need to write 0.02 x for our profits, and then you just add on that flat fee, or in this case the it is a flat fee of $50, and there's your equation. Can you do this? Go ahead and try the next one. See how far you can get. Push pause and then push play when you're ready to check, or if you get stuck. Alright, either you're stuck or you're ready for me to check. It says let x represent the number of foils and y represent the total cost. Almost all of these, they're y's representing your total cost, so they should always start with y is equal to. And then you look through the problem and try to find the foils. Here she is charged $2 per foil. So there's that keyword. Oh, there's that other keyword, that per, that also lets you know that that's that coefficient of x, or your rate. And then I covered it up with my pen mark, but the only other number in the problem was the 25, so you just add 25. See, word problems aren't that bad. You just got to read the whole problem. Okay, let's try the third one. You decide to take a taxi cab from the Excel Center to Shelbyville. Indianapolis Taxi Company charges a flat rate. That's that rate that you get charged just for getting into the taxi, and an additional $1.25 per mile. So let's write this equation. It says let x represent the number of miles. So we know y is equal to, and then find the number that's associated with miles right there. And there's that other keyword there, per. So $1.25 per mile. They did tell you to use x. You might be tempted to use the letter m, but if they tell you what variables to use, then you must use them. On the ACA, they will not, if they tell you what variables to use, they are looking that you use those variables, and you'll get it wrong, or you won't get full credit. So that flat rate of $2.50, just add it to the end. You very rarely on these problems, by the way, are going to be subtracting. I can't remember right off the top of my head if any of these examples have a subtraction in them at all. I'm trying to think of any time. Maybe if you see the word something about decreasing, then you know you might have to subtract. So let's go on to the next one. Go ahead and push pause and give it a try, and push play when you're ready to check. Okay, you ready? X this time is this linear equation to relate the number of hours you worked, x. So this is just another way of them telling you what variable to use. You'll see a description and then a comma to let you know that they want you to use that variable x for hours, and then the total amount your parent owed you. Well, there's that total amount. So we're going to use y to represent the total. And it says hours is X. So look for the number that's associated with hours. Your parents tell you they'll pay you $6 per hour. There's that word hour. In fact, there's that word per. So we know the 6 goes in front of our X. The materials cost you $9.50. Okay, so this is an example where we do have a subtraction. Whenever you have a cost, and remember when we did inequalities, remember when we said that if you're going to sell items, it costs you money to make those items? Well, in this case, this person has a job to work, but it costs you in materials. So whenever you see that word cost, that's a good indication that you're going to be subtracting. So we need to subtract from our profit that $9.50. All right, take a look at the next one. You're making coffee. The coffee pot already has 4 centimeters of coffee in it. As you wait for the percolate to make the coffee level rises 10 centimeters per minute. The equation y equals 10x plus 4 models the depth of the coffee after x minutes. And we can see that. There's that word per again. So 10 centimeters per. So they already wrote the equation for you. And that 4 centimeters, why is that 4 centimeters a constant? Well, think about it. Anything that's happened in the past, you cannot change. So that would be your y-intercept. Now this question is different from the other ones we had in the past because it says now that we have this word problem that explains a situation and we have an equation, you can then use that equation with a given value. So they want to know what is the depth of coffee after 3 minutes. So how would we have to solve that? Well, they say right here, or let you know, that x is representing the minutes. So what that means is if we know how many minutes, then we can figure out our total depth. You just are going to replace that x with the given value of 3 minutes. So let's try this. Y is equal to 10 times x. Well, we're just going to use parentheses to hold that spot for a minute, plus 4. And then you're going to replace that 3 minutes or plug that in for where that x was at. Just like that. So to find our total cost, because that's what y represents, you would have to take 10 times 3, 30, plus 4. Therefore, what's your total cost? $34. That's expensive coffee. Or no, I'm sorry, not $34. Let me go back here. You know what? I made a mistake, and it's good that I made this mistake because then I can point it out to you. Even on the ECA, you'll have word problems that you have to answer, and they do expect you to write your label whenever it's a word problem. Like, what is the final answer representing? I just put a $sign on there, so I would not have gotten full credit because I put dollars. It's not asking me for dollars. What is it asking? What is the depth? Well, the depth is, measurement, and that's centimeters, so it's 34 centimeters. Now that makes more sense. So when you're also solving these problems, you get an answer, ask yourself, does that even seem possible or make sense? That $34 for a cup of coffee, for making a coffee pot, that doesn't seem right. Well, that's not what we're doing here. We're looking for the depth of the coffee pot. So that's where the 34 centimeters come in. All right, I want you to do the last example all on your own. Try to get all the way through it before you push play to check your work. All right, let's see how you did. In this problem, once again, they already gave you the equation. So that 80 and 52 is just what they used to come up with the equation in the problem. And now they want to know how many bags will you pack if you worked for 4 more hours. So that 4 you plug in or you replace your x because that's how many hours. The x is in this case representing hours. And then plus 52. And you're solving this. Now if you're thinking that you're going to have to add this answer to something else later on, you don't. That bags you've already packed is already in this problem. That's that y-intercept. So the only thing you're doing is simplifying this expression. 80 times 4 is 320. I got that very easily, by the way, just by multiplying 8 times 4 and adding the 0 to that. That's a quick way to multiply when you have a number ending in 0, plus 52, and then we add those two values together. So our final answer, see, 320 plus 52 is 372. Now 372 what? The answer is how many bags? It'll be bags, because they asked for how many bags. Okay. So some differences between these last two problems and the previous four. These two problems, they actually give you a value to plug in. And so your answer should be a one-number answer, and it should have a label to it. Important. In the previous four problems, the only thing it was asking for is to write the equation. We can't add a label to an equation. We can only add a label to a final solution. Okay. So that concludes this lesson.